Now in properties of determinant of a matrix A, we will look at properties of enclosure matrix and solve problems based on properties. Please look at part 3 slide for better understanding. Please like, share and subscribe this particular channel. Let us start now. Now coming to important properties of determinant of an enclosure matrix. Okay. Point by point I will be explaining. The first one is two parallel lines, row or in a column, are interchanged in a matrix. Then the determinant does not changes, but the sign changes. Okay, you have to remember that sign will be changing. Okay, I'll be giving one example for it. You consider this one as an A matrix. Okay, then we will be finding the determinant of an A, which is equal to nothing but it is an 2 cross 2 matrix. Yes or no? So determinant is equal to nothing but 1 into 4 minus 2 into 3, which is equal to nothing but minus 2. Right? If you interchange the rows or columns also, right? If you consider this one as a row 1 and this one as a row 2. Now, if you interchange this one, then it becomes 3, 4, 1, 2, right? If you consider this one as a B matrix and find the determinant of an A B matrix is how much? Again, it's a 2 cross 2 matrix, so it becomes 3 into 2 minus 4 into 1. So it becomes 2. So we are just interchanging the rows, right? Then what happens? The sign is being changed. Here it is plus, here it is minus. So by changing the row or a column, okay, determinant does not change, but the sign changes, right? Come to the second point. A determinant is unchanged by applying the elementary operation. Okay, one more example for it. If you consider this particular matrix, it is nothing but A matrix only, right? Now what we do is nothing but do an elementary operation. This is not my A matrix. In A matrix, what we do is nothing but we'll consider row 2 is equal to nothing but row 2 minus row 1, right? This is an row 1, this is row 2. Is an A matrix. Yes or no? So here A matrix is equal to nothing but it becomes 1, 2, 3 minus 1, it becomes 2, 4 minus 2, it becomes 2. Right? Now we'll be finding the determinant of an A is how much? It is 2 cross 2 matrix, so it becomes nothing but 2 into 1 minus 4, which is equal to nothing but it becomes minus 2 only. See here, you're getting minus 2 here. Here also it is minus 2. Yes or no? Same matrix 1, 2, 3, 4, 1, 2, 3, 4. So by applying an elementary operation, the determinant does not change or unchanged. Right? Come to the third point. If two lines are identical or proportional, then the determinant is 0. Okay. One more example for it. If you consider this one as P matrix, you can see that row 1 and row 2, right? Row 1 is equal to row 2. Yes or no? In this case, determinant of P matrix is equal to nothing but 0. Okay. Instead of 2, 1 and 2, if you have something like 2 and 4, okay, the matrix is 1, 2, 2, 4. If you consider this one as a say Q matrix, okay, here we can see that row 2 is equal to nothing but 2 times of an row 1. In this case also, the determinant of an Q is equal to nothing but 0. Okay, one more example for it. Okay, now the fourth point. If any row or column is equal to the sum of two columns or multiples of two or more columns, then determinant is 0. Okay, one more example for it. If you consider this one as nothing but say K matrix, this one, if you see the row 1, row 2 and row 3. From here we can see that row 2 is equal to nothing but row 1 plus row 3. Yes or no? When you add 3 plus 2 it is 5, and 5 plus 7 it's 12, and 2 plus 5 it is 7. So in this case, determinant of a matrix is equal to nothing but 0. One more example for it. If you consider this particular matrix, a J matrix is this one. Here you can see that this is in a column 1. This is nothing but column 3. Right? So here column 1, when it is multiplied with an F5, it is equal to nothing but column 3. Yes or no? In this case also, determinant of an J, my matrix is equal to nothing but 0 only. These are nothing but properties of an matrix by finding the determinant of an matrix. Okay. Now coming to important points of determinant of n cross n matrix. Okay. The first one, if determinant of A is equal to 0, then A is nothing but singular matrix. Second one, if determinant of A is not equal to 0, then A is nothing but non-singular matrix. These two are very important. You have to remember. Okay. Coming to the third one, determinant of A into B is equal to determinant of A into determinant of B. The fourth one, determinant of A plus B is not equal to determinant of A plus determinant of B. Okay. Come to fifth one, determinant of unitary matrix is equal to 1. Okay. If you consider 2 cross 2 unitary matrix, then I is equal to nothing but it becomes 1 0 0 1. Yes or no? Is that 2 cross 2 unitary matrix? Then determinant is nothing but it's always 1. From the sixth one, determinant of n a k into a is equal to k power n into a, where k is nothing but a scalar value. K is nothing but a scalar value. Okay. And A is nothing but matrix. When you multiply both of them and find the determinant, then it is equal to nothing but k power n into determinant of A, where n is nothing but a matrix. Okay. If A is nothing but n cross n matrix, then it becomes k power n into determinant of A. Okay. Coming to seventh one, determinant of an adjoint of A is equal to determinant of A power n minus 1. Okay. A is nothing but n cross n matrix. Then adjoint of A, find the determinant is equal to nothing but determinant of A power n minus 1. Coming to next one, determinant of adjoint of A is equal to nothing but it becomes determinant of A to the power of n minus 1 square. Okay. A is nothing but n cross n matrix. Then find the adjoint of A. Determinant is equal to nothing but find the determinant of A whole power n minus 1 whole square. Come to the ninth one, determinant of diagonal upper and lower triangular matrix is equal to product of principal diagonal elements. Okay. If you consider upper or lower triangular matrix, if you consider upper triangular matrix is equal to nothing but like 1 2 3 0 7 5 0 0 and say 3, then its determinant is equal to nothing but u is equal to nothing but product of principal diagonal elements. So it becomes nothing but 1 into 7 into 3, which is equal to nothing but 21. Okay. You consider upper triangular matrix or lower triangular matrix, then determinant is nothing but product of diagonal elements. Okay. Now coming to questions depending on properties and important points of determinant. The first question is, which value of x will be in the singular matrix A? Right, A matrix is given here, 8x0 402 12x0. They are saying that to find the value of x such that A is in a singular matrix. What is a singular matrix? Is nothing but determinant of an A should be equal to 0, right? So we have to find the determinant of this particular matrix. Then it becomes determinant of A is equal to nothing but 0, right? Which is equal to nothing but find the determinant. It's in a 3 cross 3 matrix. Yes or no? So we consider the first term. It's 8 into the 2 by 2 matrix. It becomes here, it becomes a 2 by 2 matrix. Right? Cross multiply these two. So it becomes 0 into 0 minus 2 into 6. Right? Consider second term. It's x here. So it becomes minus x and do not consider first row, second column. So it becomes 4 to 12, 0. So determinant of again 2 by 2 matrix. It becomes 4 into 0 minus 2 into 12, right? And next term is 0. So it becomes plus 0 into again 2 by 2 matrix. So it becomes 4 into 6 minus 0 into 2, right? Here we are multiplying with 0. So this one is nothing but 0. Yes or no? And this is also 0. This is also 0. So it becomes 8 into minus 12, right? Minus x into, it becomes minus 24 is equal to nothing but, it is nothing but 0. Yes or no? So it becomes nothing but 8 minus 8 into 12 plus 24x is equal to 0. Then we can find the value of x. X is equal to nothing but 12 into 8 by 24. It goes by 1 sir, it goes by 2 sir, again it goes by 4 sir. So which is nothing but 4. So the value of x is nothing but 4. So answer the option A. Now coming to one more type of question. The question is, for A is equal to matrix and B is a matrix, find determinant of A and B, right? So we have to find the determinant of both A and B. Here A matrix is given, right? So A matrix is equal to nothing but given as 1, 3, 1, minus 2, 4, 3, 3, 1, minus 2. We have to find the determinant of it, right? And the 3 cross 3 matrix. So determinant of an A is equal to nothing but, consider the first term, 1. 1 into, it becomes 4 into minus 2 minus 3 into 1. Then the second term, it's minus 3 into, it becomes minus 2 into minus 2 minus 3 into 3. Consider the third term, it becomes plus 1 into minus 2 into 1 minus 4 into 3. First substitute the values, we get as nothing but, the value is nothing but, it becomes minus 8 minus 3 minus 3 into, here it becomes nothing but 4 minus 9. Here it becomes plus minus 2 minus 12, right? So which is equal to nothing but, it becomes minus 11 plus 15 minus 14, which is equal to nothing but, it as minus 10. So we got the determinant of an A is equal to minus 10. Now we have to find the value of B. Determinant of an A, B is equal to how much we have to find. See here, but here you can see that in a matrix A and matrix B, if you consider this one as a row 1A of matrix A, and this is a row 2 of a matrix A, and there is nothing but a row 3 of a matrix A. Similarly, it is nothing but a row 1 of a matrix B, there is nothing but a row 2 of a matrix B, and there is nothing but a row 3 of a matrix B. You can see that these two rows are same. As I know, 3 1 minus 2, 3 1 minus 2. Similarly, these two rows, second rows of A and B are same. Minus 2 4 3, minus 2 4 3. Similarly, row 1 of A is nothing but into 2. When you multiply with the 2, both of them are same. So we can say that row 1 of an A matrix B is equal to 2 times of an A, row 1 of an A. In this case, no need of finding the determinant of an A B. We be using the important points formula. Is nothing but, it becomes k times of an A. K is nothing but a multiple of an A constant value that is multiplied in row or column of an A matrix A. Then we get an A matrix B. Okay. Here the constant term is nothing but 2 value. So it becomes 2 into determinant of an A, which is equal to nothing, it becomes minus 20. Yes or no? Determinant is minus 10. Similarly, if you consider that B matrix, if you consider the B matrix is equal to nothing but, if you get something like 2, 6, 2, minus 4, 8, 6, and 3, 1, minus 2. Okay, here matrix B and matrix A both are same, but here row 1 of an A B is equal to 2 times of an A row 1 of an A E, and here row 2 of an A B is equal to 2 times of an A row 2 of an A E. Again here, again it is nothing but row 3 of an A B matrix is equal to nothing but row 3 of an A matrix A. In this case, it has been multiplied 2 times in a row. Or similarly, if it is multiplied in 2 times in a column, what you do is nothing but determinant of an B is equal to nothing but k into k into determinant of an A, which is equal to nothing but get us 2 into determinant of an A is nothing but minus 10. So which is equal to nothing but you get us minus 40. Similarly, if you get this term as nothing but 6, 2 and minus 4, then you can say that row 3 of B is nothing but 2 times of an A row 2 of an A E. Then what happens? Determinant of an A B is equal to nothing but k into k into k into determinant of an A. Here what happens? The whole terms, right? Whole of this particular matrix is being multiplied within a 2, right? So which is equal to nothing but it becomes, is in a 3 cross 3 matrix, so it becomes 2 cube into determinant of A minus 10, which is equal to minus 8. Okay, these are nothing but important points you have to remember to find the determinant of an A or B by using shortcuts.